Just let me. Yesterday we covered the processing part, and as I told you last night, processing is a subject that is not an easy subject to be covered in 1 hour or less. So we give some generic information. And the day before, we talked about the acquisition and different type of acquisition. Let me go quickly do a very quick recap for the last two sessions. Maybe some of the attendees missed them. So in less than 5 minutes, I will go through what we have done. Okay. First, we talked about the objective of the course. The first day was talking about why do we prefer seismic method in oil and gas exploration. In order to do this, or to understand why seismic method is the preferable method, we compared it with other methods like gravity and magnetic. And we knew what is the application for each one, what is the limitation, what is the advantage of seismic method. Then we talked about some definitions like wavefront, ray path, wave parameter, like peak, trough, amplitude. Then we talked about the reflection coefficient, and why do we usually have trough or peak on the wave. We explained the equation of the acoustic impedance reflection coefficient. Then we turned to the seismic acquisition, the differences between 2D and 3D, the advantage of each one of them, 3D layout and 2D layout. Also, we explained through a video what is the fold and this definition of fold and the stack power. Then we went quickly through different type of acquisition, marine land, transition zone, OBCs, 4D, and we ended up with OBN, the most recent acquisition technique, ocean bottom nodes. And we talked about the advantages of OPN. And we ended up with a little bit advanced point, which is survey design. The second day, or the day yesterday, was about processing. We gave an idea about the seismic processing, the role of seismic processing, generic workflow. This workflow, it is not fixed for all the processing project, but it is generic and contains the mandatory process. We talked about reformat, trace edit, noise attenuation, and I explained in details how this process is done inside the program, and what is the normal move out, what is the normal move out correction, and why do we do it. Before and after velocity analysis, the multiples, which is unwanted signals, we need to remove the multiples. The multiples is double times the primary, and we showed an example before and after multiple attenuation. Then we went to the migration part, which is the main target of any processing project. And what we explained what is the migration. It is a process done to relocate the traces in time of distance and time, in terms of distance and time, to go to the real geological settings. And we showed few examples, difference between time before and after migration. Then we compared the PSTM versus PSDM, pre-stack time migration and pre-stack depth migration, and why we consider the depth migration better than time migration. Give an example between PSDM and PSTM. And today now we are going to talk about the interpretation. We will talk about types of interpretation, mapping, DHI, direct hydrocarbon indicator, and a quick review about AVO and AVA. Then I will show you quickly the details of the full course. Then you can ask your questions. Okay. Types of interpretation. Seismic interpretation is the extraction of subsurface geological information from seismic data. It might be divided into structural interpretation, stratigraphic interpretation, and lithological interpretation. Within the stratigraphic interpretation, you can have subdivision like seismic stratigraphy and seismic sequence stratigraphy. What is the structural interpretation? It is directed towards the creation. Let me get the laser pointer. Structural interpretation is directed towards the creation of structural maps of the subsurface from the observed 3D configuration of arrival time. So the structural interpretation is mapping or getting structural map from the seismic data after doing the interpretation. So it's done for horizons, for reservoir thickness map. Stratigraphic interpretation. Seismic sequence stratigraphic interpretation relates the pattern of the reflection observed to a model of cyclic episode of deposition. Stratigraphic interpretation, it'll something like a certain model or certain behavior related to the depositional environment reflected or appear on the seismic section. Third type is lithologic interpretation, or DHI, direct hydrocarbon indicator, is aimed at determining a change in pore fluids, porosity, fracture, intensity, lithology, and so on from seismic data. DHI are elements employed in the lithological interpretation process. We will talk about DHI now in details. The mapping is considered a type of the interpretation or a step of the interpretation. Once the key horizons are identified and picked, maps of different layers are generated using different grading and interpolation technique. These provide a 3D view of the main surface and feature of the subsurface geology. Because while you are working on seismic section on the screen or on whatever software, it is in a 2D, but the mapping gives you the chance to check the layers or the horizon in a 3D mode. The picked time value are posted with faults on the base map and are contoured to produce a full time structure map of horizon, and then could be converted to depth using stacking velocity from the seismic or the well velocity from wells. The DHI will define what is the DHI, what is the different types, and the uncertainties of the direct hydrocarbon indicator. The DHI is measurement which indicates the presence or absence of hydrocarbon accumulation. The DHI is a change in amplitude due to change in the velocity of the rocks, which in turn is dependent on the variation in lithology and fluid content. So the variation of amplitude results in direct hydrocarbon indicator, and the variation in amplitude coming originally from the variation in the lithology and fluid content of the rocks. The DHI are bright spot, dim spot, flat spot, phasing or polarity reversal, velocity sag, shadow zone. Sometimes AVO is considered as a DHI. An example for bright spot: the filling of the reservoir sand with hydrocarbon gas would lower the reservoir rock velocity, increase the contrast, and hence increase the amplitude of the reflection from the top of the reservoir, giving a bright spot. If you remember, in the first day, we talked about why do we have trough and peak? Yeah, due to reflection coefficient and acoustic impedance. So you have peak or trough. as this contrast or variation increase, you can see the bright spot. And this is related to the difference of the density, velocity, lithology, and all the character of the rock. This high variation will cause you a significant amplitude variation. And this bright spot doesn't necessarily mean that you have hydrocarbon. For example, if you have here a layer with a certain lithology, which gives you an amount of amplitude, and you have here another lithology that gives you another amplitude value, but the differences between them is high, so you can have this high contrast in amplitude. So bright spot doesn't necessarily mean that you have a hydrocarbon. The DHI or the bright spot or DHI in general indicates a variation in the amplitude, whether it is related to hydrocarbon or not. But by the end of the day, it is a good sign for presence or possibility or probability of hydrocarbon. The dim spot is the opposite. You can see a dim amplitude. Also, it is referred to variation in the lithology. Flat spot, where the flat spot refers to the gas-water contact. If you see something like this on seismic section, it might refer to a gas-water contact. What is the uncertainties, which I already said? Not all observed bright spots represent a commercial hydrocarbon accumulation. Lithologic variation, coal bed may produce bright or dim spot in the same way gas does. The difference in water and oil velocity is usually not sufficient to create bright spots. Now I will talk about the AVO. What is the AVO? AVO, it's amplitude versus offset. Okay, we can take seismic data and process it to include all offset, which is called full stack, or select some offsets. For hydrocarbon analysis, we often get near, mid, and far angle stacks. The difference in amplitude for a target interval or near versus far stack can indicate the type of fluid within the pore space of reservoir rock. AVO analysis examines such amplitude differences. Okay, so this is the main task or the main job of AVO analysis, that you can indicate or define the type of fluid within the pore space of a reservoir rock. How this is done? First, let me explain to you what is the AVO. The amplitude value, reflection amplitude, varies with the incident angle. Okay, we talked about the Snell's law and the incident angle and the angle of reflection from the other side on a flat horizon. Okay, reflection amplitude varies with the incident angle in a way that it is related to the physical properties above and below the interface. These properties are lithology and fluid in the pores. So the angle of incidence depends on the lithology of the layer, which in turn the reflection angle is equal to the incident angle. And this also is a factor in the amplitude. These three classes are called the AVO classes, where here we can define the different features of DHI and the different fluids inside the rock. We have a class called class 3, AVO class 3. You can notice here that the amplitude increase with the angle. The amplitude increase with the angle. Here, the wave length or the amplitude increases with the angle. Okay. What is this angle we are talking about? Angle of incidence, this one. So as the angle increase, the amplitude increase. Okay. For class 2, it's increase, and in the other side, it starts to decrease, which is polarity reversal, like this. So when you have a certain horizon showing peak and then go to trough, this indicates AVO class, second AVO class, or 2B. Okay. AVO class 1 is the opposite of class 3. The amplitude decrease as the angle increase. The amplitude decrease as the angle increase, causing them spot. This is in brief or summary. Of course, each one of them indicates the variation in the amplitude, which it is if it is related to the DHI, you can expect what kind of hydrocarbon inside it. Of course, there is more analysis done on the charts to know the type of the fluid. Okay, but this is the main classes or the main features. AVO and AVA. The shallower the depth, the higher the angle, the higher the amplitude. At the same offset, shallower depth has higher angle, higher amplitude, higher AVO resolution. The shallower the event is, you will have a wider or higher angle, higher amplitude. Okay, this actually in the full course, it's a full case study where I give you some of some inputs, some information and some inputs, and you build a full workflow according to what you have learned in the detailed course, of course. So let me tell you after the full course in 1 month what you can expect or what you can learn. You can go through this workflow. You will learn how to create a synthetic seismogram on software. Okay, how you can do seismic interpretation and make use of it, and the mapping, and do the AVO analysis, and finally you get a final conclusion. This is the synthetic seismogram, okay, where it is the fundamental link between well data and seismic data, and it is the main tool that allow geological peaks to be associated with reflection in the seismic data. So the synthetic seismogram is the link between the seismic data and the well data. This is the seismic interpretation in terms of horizon and faults. After you do this interpretation, you convert the horizons into maps, okay, and you can produce thickness map. Also, you can use your synthetic seismogram on the well, on the seismic, on the seismic. So you can relate your top marker and synthetic seismogram with your seismic. And this is, for example, amplitude map produced from the horizon. For example, here, you have horizon here and horizon here. You can produce an amplitude map in this section. This also to be done in the full course as an exercise. And this is the actual AVO analysis, okay, according to the AVO classes that we just discussed. And finally, you get a final conclusion to integrate all of these tools together. Okay, you have maps, you have synthetic seismogram, you have the AVO analysis, so you can integrate all of these tools to get a final conclusion. Let me share you another document. Let me share with you another document. As Nikki said at the start of this session and then the workshop start, let me go through the detailed agenda for the full course to make it more clear for you. The first day, it will be one session talking about geophysical method, geophysics in oil and gas, seismic method specifically in details. And then it will be followed with two sessions for seismic acquisition. Okay, each session ranges between 1 hour to 1.5 hours. For the seismic acquisition two session, it will be about concept and fundamentals and the different type of acquisition, but in details. It will be covered in details. After this will be a fourth session for seismic processing, because seismic processing topic is a really a large one, where we are going to cover each step in detail with the QCs and what it is done practically in the processing center. For the next point, seismic interpretation, we will be having 3 sessions to cover the fault interpretation, horizon interpretation, stratigraphic interpretation, and depth conversion exercise on software, quantified interpretation, and bright spots or DHI in details. Then there will be a session for seismic reservoir characterization, followed by 2 sessions about the AVO and AVA. We will have a full exercise for the AVO. And finally, 1 session for the seismic inversion in details. It will be covering the seismic inversion theory, the role of inversion and inversion workflow, and case study, and a quick knowledge about 4D, an overview of 4D seismic, 4D seismic acquisition, and the relation of AVO and seismic modeling with the 4D. And at the end of this course, there will be a full session for your question and to answer. Again, let me highlight that the full course will contain practical exercises on softwares. For now, I can start receiving your questions, please, on chat. We can do this right away. Please, anyone, if you have any question related to the workshop, you can ask me.